Okay, there you go. Okay, title it Graphing Quadratic Functions. Then I'm going to have you write down something that's directly out of the book here. That box right there. The box, everything inside of this, including the graph.
Horrible.
Except I can't score from it.
All right, while you're finishing writing this, today and tomorrow we're going to take the day to be able to learn how to write using the quadratic function. We're going to learn how to graph using graph quadratics, yeah.
X equals b over 2a.
Negative b over 2a. So we're going to learn how to graph quadratic functions today and tomorrow. Today I'm going to teach you all the tools you're going to need to be able to make a graph. Tomorrow we're actually going to graph them. I like doing this. It's kind of weird, but I do. Okay, but today we're going to teach you all the tools it takes to be able to graph quadratic functions. It's not as easy as graphing a line. Plot the y-intercept, find the slope. It's not that easy. It gets quite a bit harder. I would. Skittles. It's good. Okay, so a couple things about this. One, if you ever hear the word parent function, that means the very basic of the original graph. Okay, so the parent function of this is f of x equals x squared. The standard form is something we've seen a lot of, right? Ax squared plus bx plus c. That's something we've seen a lot of the entire chapter 1. F of x just means function. It means that this graph is actually a function. It'll pass the vertical line test. There's a one-to-one relationship and so on. The type of graph is a parabola. That's the name of it, parabola. Now, there is weirdos out there that call them, is it parabola? It's not a parabola, it's a parabola. Okay? My teacher from South Korea called them parabolas. They're not called parabolas, they're called parabola. So everyone say it, parabola. I knew that. Okay, now look, this one already gives you two big keys to this. The first is the axis of symmetry. When you hear the word symmetry, Sam, what does that mean? What is symmetry? Yeah, it's a mirrored image on both sides, right? If something's symmetrical, it's the same on one side as it is on the other. So if we have an axis of symmetry, which I'm actually going to call it the line of symmetry, also there's two different names. It's the line that cuts the parabola directly in half. So the line of symmetry or the axis of symmetry cuts the parabola directly in half. And then the y-intercept is always c. So c is always off to the side, right? ax squared plus bx plus c. C is always the letter not next to a variable. What happens if there's not a c, though? What happens if we have like a graph that's 3x squared plus 12x? Yeah, it's c0. Or nothing, right? Or it never touches the y. Okay? Which happens? Well, sooner or later it'll touch the y. But more than likely it'll be 0 out there. Okay? Any questions for me? All right. Write down this problem. Right there.
That's a tough parabola. Why you always being on yourself?
Professor Zhang. Well, it was spelled Z-H-A-N-G, but he was called Professor Zhang.
That's like a sophisticated name.
He was sophisticated. He was awesome. I loved him.
The only time you also hated him talking trash.
He couldn't pronounce it. He was terrible. He'd only lived in America for like 3 years, dude.
I could learn Chinese. How would you do if you were in South Korea?
Real bad, and I bet people would make fun of me.
Yeah.
Yeah. Yeah, I know what I'm talking about. Okay.
I should put my address.
All right. So I'm going to give you the tools to be able to graph these. Everyone ready? Tomorrow we will graph them, but today all we're going to learn is the parts that it takes to graph them. So step number one. Step number one, we're going to find the axis or line of symmetry. And that is found using this formula. X equals negative b over 2a. And this is very important because you have to do these steps to be able to get it. So first step, we're going to find the axis of symmetry. We find it by going negative b over 2a. Now if we look back up here at our problem, that's our a, that's our b, and that's our c. So the axis of symmetry, we're going to have a negative b, which is 6, over 2 times 3, or negative 6 over 6, or negative 1. Now watch how I write this. Yeah, the axis of symmetry is always x equals. The axis of symmetry is always x equals. You have to write it x equals. Okay? It is always written x equals. So our axis of symmetry is negative 1. Step 2. Plug axis of symmetry back into equation and solve for y. This will give you the vertex. So what that means is you're going to get y equals So whatever the axis of symmetry is, you plug it into the x's, into your equation, and solve for y. So this is going to give us negative 1 squared, which is 1, times 3 is 3, minus 6, minus 4, or y is going to equal negative 7. Now look, vertex is always written as an ordered pair. So I'm going to do it right here. So what's the y coordinate of our ordered pair? Negative 7. You just barely found it. What's our x coordinate? Negative 1. So there's our vertex. Now, before I go on, what is a vertex? Does anyone know? Yeah, it's the highest or the lowest point. It's wherever the graph changes direction. So if we think about a parabola, so if we have a parabola like this, right? Don't draw this, but if we have a parabola like this, the vertex would be the lowest point wherever the graph starts to change direction. So from negative to positive, or decreasing to increasing. Same kind of thing if you have an upper one, right? If you have an upper parabola, the vertex would be up here, right where it starts to change direction from increasing to decreasing. That is where the vertex happens. So the vertex is the point where the graph changes direction. Questions? Step 3. Find y-intercept. It is always C. So what is the C in this problem? So the y-intercept is negative 4. Okay, those are the 3 things we're going to worry about today. Finding the axis of symmetry, finding the vertex, and finding the y-intercept. Those are the 3 things you need in order to graph a parabola. Now there is other little nuances that we have to do to be able to graph one, but as of right now, those are the 3 things that are most important. Okay, questions for me so far? Alright, let's do a couple more. And then I'm going to show you some graphs and we're going to kind of work backwards. Here we go. So if we have y equals negative x squared plus 6x plus 4. I got to look up and see exactly how they asked this question on your homework. That's what I'm afraid of. Okay. So first things first, this graph is going to open downward. The way I know it's going to open downward is because A is negative. If A is ever negative, it opens downward. If A is ever positive, it opens upward. So this one is going to open downward. What that means is this graph is going to look like this, like an N. Okay? If A is ever negative, it opens downward. But that's not, now we're just going to talk about finding our things. So step number 1. X equals negative b over 2a. Our A, our B, and our C. So, Jordan, what's our B? Just 6. So negative 6, because it's a negative b, right? Over, what's our A? Negative 1. So 2 times a negative 1 or 3. So our line of symmetry is 3. Now I did this problem on purpose because you guys have to see this. This is going to hang up a lot of people. Step number 2, we have to then plug in the line of symmetry back in to get our vertex, right? So we're going to have y equals negative 3 squared plus 6 times 3 plus 4. I see this get more people than any other thing on this whole graphing. That negative x squared up front. It gets more people than anything else. This problem right here is not negative 3 squared. This is 3 squared times a negative. Those are two different types of problems. 3 squared times a negative is negative 9. It is not negative 3 squared. When you plug something in for this x and there's a negative in front, the negative stays out in front and this goes in parentheses. Just like this. So this becomes plus 18 plus 4. So y is going to equal, is that 13? 13. So our vertex is 3 and 13. The axis of symmetry goes right here. What we found for the y goes right there.
Where does the 2 on step 1 come from?
It's part of the formula, negative b over 2a. That's the formula to find the axis of symmetry.
It's already been-
Yep. Just like this distance formula is x1 minus x2 squared. It's just there. It's there to make the formula happen. Okay, step number 3. What's the y-intercept? 4. Okay? All right, one more. Actually, I'm going to have you guys try one on your own. I want you to find those 3 things. Y equals 3x squared plus 6x minus 2. Find those 3 things. How far back can this thing tilt? I cannot read it. Give me just a sec. I'm going to print this out so you guys can see exactly what's going to happen on your homework while you guys are working on this. Give you another 30 seconds. That's military. I should be on military. All right, Daxton. Step 1, how do I do it? -6 over. Okay, so what does this give you? So our line of symmetry is -1. Is this the exact same problem as our first one? Step 2, what do we do? Allie? So 3 times the -1 squared plus 6 times the -1 minus 2. So we get 3 minus 6 minus 2, or y equals, is that -5? Is that right? So your vertex is -1, -5. To Boots, what's our y-intercept? Perfect. Who got them all right? Raise your hand. Who in here didn't finish? Raise your hand. Who in here likes to raise their hands like they just don't care? You're a jerk. Okay. All right. I'm going to show you exactly how your homework's going to look today. You guys come up and grab it. Okay. This is how your homework's going to look, though. So your homework is going to give you a graph like this, and that is not looking good. I'm wondering if this is blurry or something. Here.
It was good, and then now it goes like just.
Is it blurry? Hey! Okay!
That's for people watching this on the recording.
We're going to go through this real quick, and we're going to actually list out all these things that ask. So there's our graph. So that is exactly what a parabola sometimes looks like. So you guys are going to be graphing things that look just like that. First things first, it's going to say, is this open upward or downward? So does this one open upward or downward? Upward. I had a professor, different one, that said when the graphs reach toward heaven, they're opening upward, right? Because upward is heaven. When they're going down to hell, they're opening downward. Okay? Yeah, it was a wild day in math. Okay, it was like I can't remember the class, but it was a wild day. Okay. Now look at this. It says the equation of the axis of symmetry. Now, I told you something. The axis of symmetry is always what? X equals. You have to put X equals. Now, if you look at this graph real quick, the axis of symmetry would be the line that cuts it in half. So you may have to look or draw it out or see it, but the line that cuts the parabola in half is the line of symmetry, or the axis of symmetry. So it actually, I'm going to be able to tell you, so it actually goes through -4. So wherever it goes through the x-axis, +4. So wherever it goes through the x-axis is your line or axis of symmetry. That's why it's called the axis of symmetry, where it goes through the x-axis. Okay? Then it's going to have you go over the x and y intercepts. Now, I'm going to just tell you, you guys can be able to see x and y intercepts. Most of these will have 2 x-intercepts, but sometimes they have 0, sometimes they only have 1. This varies based upon the problem. If it touches it like that. Okay? So x-intercepts would be 6 and 2. The y-intercept would be 3, and I know you can't really see that very well, but I can, okay? Alright? There we go. And then the last thing, it says find the coordinates of the vertex. How do I find the vertex? Look at the graph. So look, we know one thing. We know the y-x coordinate of the vertex is 4. Okay? And then you got to look, okay, it's going to be the point at which it shifts direction. So it shifts direction at 4 and -1. So your vertex would look like this. Okay? So let's look at it full length here. Now you kind of know what it looks like, and I'm just going to walk you through it. Alright. So, Daxton. Not Daxton. Kate, does this one open upward or downward?
Are you K-Max? Is that your new name?
Downward. Good. Now it says find the coordinates of the vertex. The vertex is the point right here where it changes direction. So your vertex would be 2 and 1. Okay? Now look at this. The equation of the axis of symmetry, stay with me just for a minute longer, is whatever line goes through the x-axis. So it'd be x equals 2. Now notice here, something very unique to pay attention to. The x-coordinate of your vertex is the same thing as the axis of symmetry, always. The x-intercepts would be 3 and 1. And the y-intercept is -3. Okay, this is what you're going to be doing today on your homework right here. Okay? It's on Alex, go. Hot outside, Jackson.